The Usability Software Engineering Modeling Environment, USME, is a systematic methodological approach to evaluate the usability of domain-specific languages during their development for application domains that target large end-user groups. Domain-specific language, DSL, is meant to close the gap between problem and solution domain by reducing the need to use technical concepts and focusing on the domain concepts. USME highlights the complexity of relevant knowledge that should be traced during an iterative and incremental DSL development lifecycle. It aims to cope with the need for systematic evaluation approach which answer the question, did I build the right DSL, from the perspective of their target end users. User interface community commonly perform these kind of evaluations by assessing a quality news characteristics. USME support quality news assessments for DSLs by taking in consideration context dependencies of usability indicators and enabling the design of empirical studies and controlled experiments with end users. Provided model-driven approach is illustrated by several modeling activities from a perspective of expert evaluator, which often is not included in the DSL development process. Among several case studies which were performed during a research process, we will present the USME approach on a case of development of a DSL meant for children to program low-cost robots, named Visualino. The USME prototype was developed as a specialization of a conceptual framework to illustrate the feasibility of the proposed approach. A prototype tool was integrated with an existing Eclipse-based environment, enabling language engineers to take the role of expert evaluators when preparing the evaluation models. The environment offers a Project Explorer, Model Explorer, and Properties window. First, we introduce the utility package, which supports mapping with DSL development artifacts. DSL instance is created in a utility specification, which maps to Visualino language model and is associated to its concrete and abstract syntax. Functional goals like provide functionality to program a robot are mapped from an existing Visualino goal model. They are associated with the functional requirements which need to be implemented for the achievement of the goal. Finally, we can map artifacts like activity or use case diagrams in a process model instance by associating a link to a project or required tool as an outside reference. The process of usability evaluation using a USME framework is presented as an activity diagram. First, it is necessary to perform a context modeling activity to specify a context model. USME prototype environment provides serious graphical editor, which helps to have a better overview of the model specifications. The context modeling starts with prioritizing the initial user hierarchy, which is represented by the DSL stakeholders. Therefore, we are having a DSL stakeholder as a root element of the hierarchy, and its sub-profiles defined as domain expert, end user, expert evaluator, and the language engineer. For the case of Visualino, the target users are children, which usually are not experienced with the programming. As such, the usability evaluation of the language with its end user is highly important. We set up the priority of end user profile to be high and classify its subprofiles by logical expression age, which is set to be 7 to 19 for a child and more than 19 for adult. After the initial prioritization, user profiles are classified and now we characterize users by profile templates. We create a templates diagram for a child user profile. Child inherits the templates from its parent and user profile, and is further specialized by its own templates which can change the definitions of parent's attributes. Child template overrides the age characteristic which was used as a classifier of its parent. The classifier expression serves to distinguish between the end user subprofiles. Profile templates are categorized as a background demographics and background knowledge and are described with logical expressions. For instance, the expression mathematics makes part of the child knowledge template and can be instantiated by experience scale or a school note. The context environment is described by elements which can be reused from architectural descriptions or feature diagrams of the DSL. We distinguish technical, social, and physical environment. For the case of Visualino, we specified the technical environment by mandatory variable reflecting operating system which will be supported, like Windows. Finally, we create a workflow specification for a context model. A workflow V1 poses a scenario in which the actor, end user, wants to program a behavior of a robot, specified in a context environment. In the case of Visualino, use case specifications are designed with UML language. These specifications are referred in the utility process model artifact and associated to the workflow. Several scenarios are associated with the workflows, which represent a small user stories. For instance, for workflow V1, we create 4 different scenarios, of which one scenario can be composed of several others. The context modeling answers to the questions: who will use the DSL, where will the DSL be used, and how is the DSL expected to be used. Following is to perform a goal modeling activity and specify the goal model. The UseMe goal model specifies objectives that the user may have while using the DSL and trace the success of the DSL under development, making it a central part of the UseMe framework. Activity starts by specifying as a root the highest evaluation objective, that is to achieve quality in use, and can be set as an extension to existing goal model. Quality in use is prioritized as a high, indicating that usability evaluation is highly necessary for Visualino development project. The actors responsible for achievement of the root goal reflects all stakeholders included in the development. For instance, the actor Visualino development represented the language engineers from company Artica responsible for Visualino development. The scope of usability goal describes the part of a context model to which it applies. In a case of Visualino, the quality in use is divided into 3 sub-goals, which are relevant for different user profiles and reflect different workflows from the context model. We further divide goals into the sub-goals for which evaluation the responsible is just one actor with expert evaluator profile, like for usability goal U1. Usability goal U1 specified that the language evaluator evaluates the usability to program a robot. To evaluate this goal, Visualino development need to provide functionalities referred in a functional goal F1, which answers to the question which scenarios are verified to be programmable using Visualino. The measurable method is specified as a programming a use case is usable and associate workflow scenarios as test cases. To use these scenarios, Visualino development need to verify a functional requirement stored in a functional goal F1. Finally, usability requirements are specified in a way they can be measured in the current phase of development. Their metrics definitions can be extended in later evaluation cycles. The learnability requirement is, for instance, measured by success to reuse the knowledge of programming a use case. Goal modeling activity helps to answer the question why the DSL is being developed. Further, it is possible to perform evaluation modeling activity and define evaluation model, which highlights evaluation goals and their corresponding evaluation steps. The first is to model the evaluation objectives. The evaluation language of the presented study is Visualino and is associated to its DSL artifact. It was found useful to compare its early prototype to other widely used language developed for children to program robots, Lego. The used Lego version is stored as additional DSL artifact in the utility. The participants of experiment are meant to be high school students. They match the teen user profile, which is age-restricted subprofile of child. The objective is to evaluate the usability goal U1, so each evaluation goal is defined to validate one of its usability requirements. First, addressing the effectiveness, and second, satisfaction. The research questions are specified in the form of a problem using the goal quality metric template from which we derive the experimental hypothesis. The evaluation context instantiates the environmental variables associated with the scope of usability goal in the way that they are comparable for Lego and Visulino language. For instance, by taking a robot configuration which is applicable to both DSLs. The evaluation context also associates the user profile of participant and the workflow that will be used. We select the experiment scenarios from workflow that are suitable for experiment and create a teaching and evaluation documentation from them. In Visulino case, evaluation scenario aggregates the teaching scenarios, ensuring that participants will learn all the relevant concepts. Finally, we specify an experimental process as an activity diagram. The test model is crucial for the assessment process and can be defined as an interaction model or a survey model. The UseMe survey modeling activity enables us to specify a survey as a background and feedback questionnaires. Background questions can be extracted from logical expressions contained in user templates which are associated to teen user profile. For instance, question 1 addresses the classifier age, which imposes the condition that participant is aged 13 to 19. This question indicator type is set to be demographics and serves to group the demographic related questions. The feedback questionnaire is designed to measure the usability requirement satisfaction. For instance, the question 2, did you find it difficult to program the robot to move in front, indicates confidence of the participant regarding the learned scenario, program robot to move front and back. The scale for all satisfaction questions reflects positive or negative experiences. To instantiate a test model as an interaction model, we perform interaction modeling activity. The interaction model is specified for the task named challenge, which is associated with the concrete scenario from the evaluation context and is expected to be performed by participants during their interaction with the DSL. We encapsulate the interaction syntax from both Visulino and Lego into the interaction model in order to document which abstract and concrete syntax version was used during the event capturing process. Further, 3 events are defined to be captured. Events effectiveness video and effectiveness live are meant to collect the data which will measure usability requirement effectiveness, described as the correctness of solving challenge task. They capture success or fail of modeling the captured concepts. Result analysis is set to be manual observation. When the evaluation model is ready, we can proceed with the evaluation execution. The next step is to analyze the stored results of the test models and to create the report model during report modeling activity. To calculate the evaluation results of the report model, the results of the interaction and survey test models are documented. Survey results report the answers to the questionnaires, while interaction results report on occurrence of interaction event concepts. They are correlated to evaluation results, whose objective was to analyze the effectiveness and satisfaction requirements for each language. The statistical analysis documents are signed as outside reference properties. Based on the results, we created the recommended goal model recommendations, consisting of new requirements associated to the functional goal F1 and usability goal U1. Report model recommends a goal model extensions and calculates the success factor of the evaluated usability goal U1. Success coverage of the goal specifies for which scope the success factor applies. Finally, it is up to all DSL stakeholders to decide to continue to the new evaluation cycle or finalize the assessment period. The UseMe approach is applicable during any DSL development phase. However, we can integrate it in a way that one cycle of UseMe process is performed during one DSL development iteration. Through the domain analysis, context modeling, and goal modeling activity can be performed. During the DSL design phase, the evaluation modeling phase can start. In the time of the implementation phase, survey modeling and interaction modeling activities can be conducted to produce test models. During the testing phase, the evaluation is executed and the report modeling activity can be performed. The usability software engineering modeling environment, UseMe, addressed the problem of the absence of the systematic approach for the DSL usability evaluation. It is specified as an iterative process which integrates well with the DSL development phases. Functional tool prototype supports language engineers in modeling usability evaluations. The presented work will continue to improve the usability of approach support, namely by evolving the tool with the guiding and verification increments, development of the usability catalog, and integration with other DSL development and usability assessment approaches. More information about UseMe approach and its applications can be found in presented publications. Thank you for watching this video.